So, in order to solve question 1A1, we will first write down every information that we have at the top. So, in order to solve this question, we need to use theorem 2.7, that is n minus 1 times s squared over variance will be approximate to chi-squared n minus 1. Next, we will equate this n minus 1 times s squared over variance and equate it to 29 s squared over variance. So we know that the degrees of freedom is n minus 1 is equal to 29. So the distribution of 29s squared over variance would be chi-squared 29. Next, move on to question 1A. We will first need to construct a 100% confidence interval for standard deviation, which means that 1 minus alpha is equal to 1 and alpha is equal to 0. So we need to write up the formula that is P in the bracket chi-squared 1 minus alpha over 2, 29 is less than or equal to chi-squared 29 is less than or equal to chi-squared alpha over 2, 29 is equal to 1 minus alpha. And then we will change our chi-squared 29 into 29s squared over variance. It is an information that we have already got on question 1A1. And after that, we'll move everything except for the standard deviation to the left hand side and the right hand side carefully so that there is no mistake. And lastly, we'll get the answer for the 100% confidence interval for standard deviation. Okay, next we will solve and find the 95% confidence interval for standard deviation if s is equal to 3.2, which means that 1 minus alpha is equal to 0.95 and alpha is equal to 0.05 and alpha over 2 is equal to 0.025. By having this information, we will put it in the formula that we have on the bottom left, and then we will put the chi-squared table so that we can get the value of the chi-squared. So we know that chi-squared 0.02529 is equal to 45.722, while chi-squared 0.97529 is equal to 16.047. By putting every information into the formula on the bottom left, we will get that 95% confidence that interval for standard deviation is between 2.5485 to 4.3018. Now we are going to answer question 1B1. So first we need to list down all our information, and then we'll know that the variance is unknown and n is less than 30. Next, we are going to find our S pool, and the answer would be 19.3431. So moving on to the right, we'll see at the top there is a formula for the t distribution, and then we need to find our t distribution value by using interpolation, and we'll get the answer is 1.6775. Next, we will put everything, every information in the formula. Next, after we have finished putting everything inside the formula, we need to read back the question, and we know that 4.127 is less than or equal to mean 1 minus mean 2 and less than or equal to 23.873. So in order to find our x, we need to solve for x on both left hand side and the right hand side. For the left hand side, we'll get 136.846, and for the right hand side, we'll get 135.154. After getting this answer, we need to add both of them together and divide them by 2. So our final answer would be x is equal to 136. Next, move on to question 1B2. Based on the confidence interval in 1, can you conclude the average monthly transportation expenses are the same between city X and city Y? Justify your answer. So the answer would be no. As the value 0 is not included in the interval, thus the two means differ significantly.
Now proceed with question number 2. A study was conducted to compare the mean number of emergency calls per day at two medical centers in a large city. The number of calls was recorded daily, and the sample statistics are listed below. So we have the medical center A and B and their respective sample size, sample standard deviation, and sample mean. Assuming that the number of calls for both centers is normally distributed, answer these questions below. For question 2A, Construct a 1 minus alpha 100% confidence interval for the ratio of the variance for the number of calls for center A and B. Okay, for this question, since we have two variants, we will use the F distribution, which means we will follow the formula to find the estimation of the ratio of two variants. Okay, so now F is equal to sample size, the first sample size times with the second variance over the second sample size times with the first variance. Now, we will move the sample size to both side, to the lower and upper bracket, leaving the two variants in the middle so that we can find the value of it. And then that will be the formula, that will be our answer for these questions. Okay, for question 2b, find a 95% confidence interval for the ratio of the variance. Okay, so now we will use the answer that we have derived from question 2a, and we will insert the value from the question itself, which is alpha is 0.05 and 1 is 7 and 2 is 13. Sample size is 7.4 and 5.3 for the second sample size. Okay, so now we will input those value, and we will find that our answer is between 0.5226 and 10.4683. So for question 2C, based on our answer above, can we conclude that the variance of number of calls for both center are equal? So now explain our answer. So to prove this, we simply have to equal our variance to 1, and to find the answer, the variance must have the value 1 between the interval. So since our answer have the number 1 in between interval, we can conclude that the variance of number of calls for both center are equal because of the same reason, which is the value 1 lies between the variance. Now, question 3. A researcher selects sample of bottled drinks at random and obtain the volume of bottled drinks which given as follows. So now we have 15 samples. And now we go to question 3a. Okay, for question 3a, calculate the point estimate for average and standard deviation of bottled drink volume. Okay, so now for this question, they ask for two answers, which is the average and standard deviation. So for average, we will find the x bar, which is equal to the summation of xi over n, and we will get our answer it to be 31.58, where n is the number of the volume, the number of sample is 15. Okay, for standard deviation, which is s squared, we will find it by using the formula of summation of xi minus a mean squared over n minus 1. For this, we will find the answer to be 0.8368. Okay, so now for question 3b, find the 99% confidence interval for the average volume of bottled drinks. Assume that the population is normally distributed. Okay, first now we need to identify the distribution that we will use. To find it, we will look at the number of n, which is 15. 15 is lower than 30, so we will use the t distribution. Okay, so the formula for t distribution is as I write here, which is negative t alpha over 2 n minus 1 and t alpha over 2 n minus 1, where the our value is in right between those two calculation. Okay. So we will get, after derive it, we will get x bar minus t alpha over 2 n minus 1 times with s over square root of n, and x bar plus t alpha over 2 n minus 1 s over square root of n. And then we will input our value that we have from question 3a, where we will get our answer lies between 30.9367 and 32.2233. Thank you for watching.